Let us discuss these three problems. First is the good array. So basically we are given two integers n and k, and basically we are given an array of n size, and it is said that for every I you choose, there has to be at least ceil of I by k 1 from the start of the array A, and also from the end. So that is the condition which is given, which should be satisfied for every I from 1 to n. And here it is given what does this ceil means. So we have to find the possible minimum possible number of ones in a good array. So basically, if we if we look about it, wait a second. Yeah. So here, if we see what it actually means is, if we want to have like minimum number of ones in which satisfy this condition, we can see that first of all we must have ones at the first and the last position. Reason being, for I equal to 1, uh, it always has to be 1. I mean, when I would be 1 and k would be anything from 1 up to whatever maximum range it is given as n. For I equal to 1, it will always be 1. Ceil of 1 by k would always be 1. So we have to have 1 at the first and the last position as per the condition. Now after that we can simply have ones, these ones at the position. Let's say if we start from the very left side, first of all we have to have at the first position 1, and then after that we can have this 1 at 1 plus kth positions. The reason being, up till 1 plus k minus 1, the ceiling of this I by k would always be just 1 only, and after that position, I mean at the position I plus k, the ceil would be increased by 1. That is why we have to put these 1 firstly at the first position, then at 1 plus k position, then 1 plus 2k position, and so on. And there is one exception over here. If by chance, let's say what let me tell you how I approached this problem over here in this code. What I did is, here I have this nk answer and l0 and r I have put I have wait okay, so I have assigned this r to n minus 1. After that I have taken answer equal to 1, since I have assumed that I have counted the 1 at the position r, that is n minus 1. Now here I have this while loop l smaller equal to r, and I am doing answer plus plus, assuming that we are putting 1 at the lth position. Initially l is 0, so we are putting l at 1 at the 0th position, and what we are doing then is l plus equal to k. And since we are incrementing answer prior to anything, we have this check condition. If in case this l corresponds to r, I mean l becomes equal to r in any condition, then we have to decrement it, since we have already calculated the answer for r equal to n minus 1, and we are not changing r, as you can see. Otherwise we are simply doing l plus equal to k, and we have to output the answer. That's how I approached this problem. Now let's see another problem. I mean the problem b, lamps. So let me first explain the statement what is given in the problem. We have n lamps, and which are numbered from 1 to n. Each lamp I has two integer parameters ai and bi. Basically ai is just a parameter. It doesn't mean anything. It doesn't have anything to do with its state. And bi is the points we will get after turning any lamp on. So we have this three states of lamps, that is on, off, or broken. So initially, remember, initially all lamps are turned off, and in one operation we can select one lamp which is turned off, and also obviously it should not be broken, and we have to turn it on. And when we turn it on, we receive bi points. Let's say if we are turning ith such lamp on, then we will receive bi points on turning that lamp on. And following operation occurs or happens after each of the operation we perform. So after we turn on any lamp, then let's say after turning that particular lamp on, let's say the total number of lamps on are x, then all the lamps who have this AI, remember I said there are two parameters, so AI is one such parameter. So all the lamps with AI smaller equal to x will simultaneously be, they'll get break up. So they will get, so all the lamps with I such that AI is smaller equal to x, they will simultaneously break, whether they are turned on or off. So, and one more thing to remember, if let's say any lamp which was under this thing, I mean, whose AI is smaller equal to x and it was turned off, after this event happens, it becomes off, or I mean broken. So obviously it gets off and the count decrease accordingly. So it is given that we can perform arbitrary number of operations and we have to find the maximum number of points we can get. So let me tell you how I approach this problem by explaining you my code. So first of all, what I did is I took the inputs and I had this vector of vector with size n plus 1, and simply I took the input and I pushed back this point thing in the particular AF lamp, I mean the lamp with the particular AI parameter. So I basically stored the point of lamps according to their AI value. So all the points with a particular AI value, I mean there could be multiple lamps with just one AI value or A value. So all of those points will be stored in a single vector. And I also calculated a max, like what is the max number of this A or the point, although it is not very much required, but for efficiency purpose I did this. And then I simply iterated from 1 to n and simply sorted this the all the given arrays in descending order. And also I pre-calculated the points given, since they contain nothing but points. So I started from one or the second index and accordingly did this to calculate the prefix sum. Now I simply got this while loop where uh, I I put this condition current smaller equal to max. Initially I assigned cur equal to 1 and max equal to 1. Actually this max will get updated over here, but cur is equal to 1. So it basically means I am at the current A number. Basically current signifies the number of A, like the parameter A. So it means like I am at the current parameter, means I have started from 1 and I'll go up to maximum since I have already calculated max. So if I didn't have this mx or I haven't calculated this mx over here, then I have to have this as n, since we can have this a up to n. So after that I simply did, if in case the given the current array doesn't have any point, or it basically means there is no lamp with particular current value, then we can simply do current plus plus and continue. Otherwise if there is even a single lamp present, then we can simply do first of all calculate tp equal to cur minus 1 and simply add this value. So now what we are basically doing is, if you can see, let's say if there is a lamp with a value 1, then I can simply add the maximum number of points of that particular lamp. So for a equal to 1, I can simply add the first maximum point of lamp 1. Then the total number of lamps on at that particular time would be 1. But as soon as we get to know that total number of lamps turned on are 1, all the lamps with AI smaller equal to 1 will get break. So the current lamp, I mean since we have started from 1, so the current lamp will also get breaked up, although every lamp with AI smaller equal to 1 will get breaked up. So the value of this open lamp will become 0 again. Now since all the lamps with a equal to 1 are been broken, and we have already got our point with maximum possible points in CR equal to 1 or a value 1, then we have simply incremented our current plus plus. That means we are now on current equal to 2. That means we are going to process the lamps with a value as 2. Now since previous at the previous state every bulb or the lamp got broken up, so now the current number of turned on lamps is 0. So here we can, what we can do, we can add up at most 2 lamps to our, or we can turn on at most 2 lamps. After we turn the second lamp on, the total number of turned on lamps quantity becomes 2. And since we are at particularly at the current equal to or a equal to 2 position, or we are processing the a equal to 2 with lamp, all the lamp with ai smaller equal to 2 will get breaked. So it shows a trend, it shows a sequence that for one we can process maximum one lamp with maximum profit, and for two we can process 2 lamps with maximum profits, for three, and for four, and so on. If in case there are not enough lamps present in that particular value of a, then we have simply mentioned over here as min of TP. TP is nothing but this CR minus 1 to access the current or the ith number of lamp. Like for cur equal to 2, we have to process the 2 lamps. Okay. So if let's say in any case there are not this much of lamps present, then this much of lamps present, then we'll simply access this value, which is the last value present of particular parameter A. And to make this process efficient, we have already calculated the prefix sum value. So we are simply doing answer plus equals to this value, and we are doing cur plus plus as I explained, and simply I have outputted the answer over here. Now let's discuss the third problem, that is C, insert 0 and invert prefix. So what I did in this problem is, what I did in this problem is, first of all let me explain the problem. So we have this sequence a1 a2 up to an, and each element is either 0 or 1, so it is a binary sequence. And we have a sequence B which is initially empty, and we have to perform, like we are going to perform n operations, and each operation will increase the length of this sequence B which is initially empty by 1. Basically what this operation say is, we can insert 0 at any position, but whatever position we are inserting this 1, we have to invert all the previous values if they are present in the array. It means, let's say if there is an array 0 0 1, 0 0 1 0, then, and let's say if I am inserting this 0 at the third position, means 0 0 1 0, and I am inserting at the third position, then the new array will be 1 1 0 1 0. So that's what it means, the operation. So we basically have to tell them if by doing all these n operations, can we like get the given array A from this array B. That's what we have to like tell them. So let me tell you how I approach this problem. First of all, one thing to note over here is this P is from 0 to I minus 1. So we can always insert 0 to the very first position and keep it inserting however times we want. So what we first of all like the initial observation I had is, we can have as many as 0 as we want, we can have but I have to have, like if I have 1 at some position, then I must have 0 after that. If it is the situation anywhere in the array that I have 1 and there is no 0 after that, not even a single 0, right? There should be at least 1 0. But if such a situation is present, like such an array is given, then we cannot form that array from the B or the given operations, which basically means is, if we have at the last position 1 present, then we cannot make any array. Otherwise, we can always make the array from the given operations from the array B. So that's why in this case and in this case, the answer is 0. Since the reason is very simple, because what we are basically doing is we are inserting a 0 and only inverting the elements prior to that. So there will always be a 0 at the latest position or the rightmost position present. So according to the operation I am saying. So if in the array A there is no 0 at the rightmost position, it means the array, we cannot get this array from the given operations, because according to the operation there must have at least one 0 present at the rightmost position. So that's what it says. So the base case, we understood that if at the last position the value present is 1, we cannot make this array. Otherwise we can make. Now let's see how to do it. Let me tell you my approach, how I approached this problem. So let's unroll it kind of. We will go from back to forward. I mean, rather than creating this array, we will destroy this array, or we will dismantle this given array. So what I did is, I can always like see the operation is like, let's say initially if this array would be 0 0 0 0 4 0, and I have to insert a 0 at the third position in the 0 0 0 0. That means inserting the 0 at the third position means there would be a 0 at the third position, and the elements present at the second and the first position would be inverted. So according to 0 0 0 0, if I insert a 0 at the third position, the final answer would be 1 1 0 0 0 as given. So what I can do from that is, if there are consecutive ones present, what we can do is, we can remove this the 0 just after those consecutive 1 and change these ones to 0. So after this operation, it means we have to insert at this position, so I will put this position in my I choose one answer vector, and I'll put this position in that answer vector, and the after that, performing this operation, the answer would be 0 0 0 0. If let's say I get this answer, if the final answer would be 0 0 0 0, that means I can simply get it. How? We can simply like put all the zeros at the 0th position, and that's how we can make this array back. So since we are going from back to forward, or dismantling the array rather than building it from scratch or from 0, so I can simply put in my answer vector this third position, or sorry, this second position, since we have to put in the third position. Then okay, I confused it. Actually it is 2 only, since if I'll choose 2, then it will be inserted at the third position. So in the answer vector I'll push 2. After that the array will be 0 0 0 0. Then I don't have to push anything in my answer vector. I'll simply reverse my answer vector, since we are dismantling the array, but we have to actually in real form the array from the 0. And since my answer vector would be having whatever is required to build up the array, but apart from that, so this 0 0, the remaining zeros can be built simply by inserting the 0 at the 0th position only. So by that, the 0 will be inserted at the first position and nothing will be changed, and everything will be shifted to the right. So that's why the answer for this, although it is given in this array as 0 0 2 1 3, but the answer according to me would be 0 0 0 2. Okay, as per my code, you can see over here as well. Let me show you 0 0 0 0 2. Now for this array the answer is no, for this one also no. Now let's see how I build this array. So basically we can remove wait a second. So we can remove this 0 by dismantling. Then the array would be simply 0 1 1 0 0. Now 0 1 1 0 0 means we have to, now 1 1 is over here, so we have to remove this 0th, since it is shown 0 over here, but after performing the operation of the performing this operation, this array would be inverted. So it would be 0 1 1 0 0. So now 1 1 are over here, so we will remove this 0th 0th element. then this array would be inverted. Now this one is 0 1 1, it will become 1 0 0. That's what it will become. Then we can remove this particular 0, then this one will be inverted again and it will become 0. Now whole array becomes 0. So we will basically put this position, which is 0 1 2 3 4, wait, 0 1 2 3 fourth position, and then we will have this position, which is 2th position, then we will have this position, which is 1th position. So basically it means we can have, oh, I again did this mistake. It is, these are first position, third position and fifth position. Since 5 is over here, wait a second, 0 1 2 3 4 5, this is 5, then 0 1, wait a second, 0 1 2 3, this is 3, and 0 1, this is 1. So this much in the array, and we will, since we have like put it these values in answer vector in the reverse manner, we have to reverse it once again, and now the array is remaining 3 zeros, so we will put those zeros as well. So the final answer would be 0 0 3 1 3 5. So how I did it in the code is, I simply took the input and assigned this L equal to n minus 1 and simply took my input given. Then if the last element is 1, I outputted no, otherwise the output would be yes. And while L is greater equal to 0, I am simply doing this while L greater equal to 0. And now why I am doing this AL equal TP? Now since every time if I start like doing this inversion thing, it will become very inefficient and I'll get a TLE. So after every inversion, we basically have to check for consecutive ones. But after every inversion, those one will be changed to 0 and again 1 0 1, so and so on. So that's why I simply took this TP. So TP is initially 0. So as soon as we arrived at since we have started from, you can see L is n equal to L equal to n minus 1. Since we have started from the rightmost position, as soon as we get 1, I mean AL equal to 1, we will break out from this while loop, the inner one. So initially we have this TP equal to 0, and as long as we have this AL equal to TP and L greater equal to 0, we are doing L minus minus. And as soon as this condition becomes false, means AL becomes 1, we will break out from this loop, and we have to we will simply push back the L plus 1, since L is at the position of 1, but we have to remove the 0 after that one. That's why we are pushing back L plus 1 in that answer vector. And after that, since pushing that answer will make the array prior to that or previous to that inverted, we are also inverting this TP. That's how we don't have to invert the whole array given previous to the the position from which we take our 0 out from the array. That's why we simply did TP XOR equal to 1, which basically inverts it from 0 to 1 and 1 to 0 and so on. And after this, we will simply reverse the array and we will output 0. These 0 are n minus answer dot size, I mean the remaining zeros in the array. And after that, we'll print the the stored answer in the answer array, and that would be the whole answer. That's how I approached this problem. I hope you got the solution. Please like the video and subscribe to the channel. Thank you.